For millions of years, human survival relied on a simple biological rule: avoid jet black food. In the natural world, that intense darkness serves as a universal warning sign for rot, disease, or poison. Yet this pitch-black plate is a prized Mediterranean and Asian delicacy, pasta, and more like a bundle of thick black wires or coils of liquid darkness. This creates a unique culinary problem. How do chefs convince us to eat a substance that triggers our deepest biological alarm systems? Solving that problem requires us to view this plate as a complex map of biological and chemical interactions. The visual shock of the dish is the foundational element of the experience, providing the base for a triumph of culinary engineering. The key to the mystery rests at the top of the dish, the roasted cephalopod that provided the ink. To understand why this ingredient behaves the way it does, we have to look at the squid in its natural oceanic habitat. Inside the squid's mantle is the ink sac, a specialized organ that serves as the creature's primary evolutionary defense. When threatened, the squid expels a biological smoke bomb. This dark cloud is designed to instantly blind and disorient predators in the open water. Creating a cloud dense enough to obscure a creature in the ocean requires immense evolutionary pressure, resulting in a compound that physically blocks light. The foundational ingredient of this luxury meal was engineered by nature to function as a chemical weapon. Culinary preparation involves taking that concentrated defense mechanism and kneading it directly into traditional staples like flour and water. The resulting dough turns black because of a single pigment, melanin. This is the same chemical compound that provides pigmentation in human skin. Melanin's dense molecular structure absorbs almost all visible light waves. Because very little light reflects back to the eye, the noodles take on a void-like appearance. While the color is striking, the ink's primary culinary value lies in its chemical payload. Squid ink contains high concentrations of glutamic acid. Glutamic acid is the chemical trigger for umami. It provides a deep, briny flavor profile that standard wheat flour cannot produce on its own. The addition of the ink transforms the noodle from a neutral carrier into an active, flavor-dense source of umami. Notice the surrounding elements: the yellow-orange cream and the threads of red chili and saffron. Pure umami has a heavy, rich profile that can quickly exhaust the human palate if it isn't balanced. This diagram represents the flavor profile of the ink alone. To make the dish edible, the chef must introduce chemical counterweights. Tomato paste provides acidity, cream adds fat, and chili threads deliver heat. These three components bring the intense umami of the noodles into equilibrium. This chemical balance is reflected in the visual presentation, where warm colors are placed to stand out against the absolute black of the pasta. The final arrangement functions as a sensory equation, where every color and flavor strictly relies on its chemical opposite. Looking at the entire history of the dish reveals a surprising narrative of adaptation. It traces a line from a marine animal's survival mechanism to a refined, multi-sensory dining experience. It highlights the ingenuity required to identify the culinary potential hidden inside a biological deterrent. This dish suggests that culinary excellence is often found by investigating the ingredients that our instincts tell us to avoid. Narrow dyspepsia succeeds by subverting a primal biological warning, using a chemical defense mechanism to create the deepest flavors found in nature.